In this video, we are going to learn how to visualize and summarize data using a table. And we're going to start off with an example. We have here 20 grades from some class. And we want to turn this data that we have here, which is just a list of the grades, into a table. So first of all, the total's 20. That's going to be useful for later. You could double check by counting if you want, but it's 20. Okay. And we want to put this in a table. Now, before we do, I want to point out that the data as we have it here right now, it's hard to interpret, right? We have everything there, but it's hard just looking at this to see, do we have more A's, or do we have more B's, or do we have more C's, right? Because it's just all spread out, it's hard to really interpret this quickly. So a table is going to allow us to do this more quickly. So how do we draw a table? So we're going to start with two columns here. The first column is going to be whatever categories we're splitting the data into. In this case, the categories that we have are the grades, the different grades that the students have. And the grades could be A, B, C, D, or F. In the second column, we are going to have the frequencies of each grade. Okay? Frequency here is just a fancy way to say how many. How many data values in each category. Okay, so when you see the word frequency, what you should think of is how frequently does this data value appear in our list of data. Okay, literally all we have to do is count how many times it appears. Okay, so I'm going to go back to my list of data here, and to fill out my table, I'm going to go one grade at a time and just count how many there are. Okay, so I'll start with the A's, and as I go through, just to help me keep track, I'm just going to cross out the grades that I've already counted. So 1A, 2A, 3A's, 4A's, 5A's, and that looks like all the A's. Okay, so there are 5 A's total in my list of data. If I now do the B's, same thing. I have 1B, 2, 3, 4, 5, 6, 7 B's, and that looks like all the B's. Okay, C's, 1, 2, 3, 4, and 5. 5 C's. D's. Now most of these are crossed out, but I do have one D over here. And then F's should be anything that's left, and I do have 2 F's. Okay, now everything's crossed out, so I know I counted everything. Okay, this kind of table where we just count all the different categories and how many data values are in each category, this is called a frequency table. Okay. Notice how much easier it is to interpret this frequency table and to quickly understand what's going on with this data as compared to our list of variables above. Okay. Up here, it was really hard for me to decide, do I have more A's or B's or C's? Now if I look down here, it's much easier for me to immediately see, oh, the grade that occurs the most often is B. I have more B's than any other grade. Right? I could also immediately see I have the same number of A's as I have C's. I don't have many D's and F's, right? I can see all that almost immediately looking at the table. Whereas looking at this, just this jumble of letters, it's very hard for me to see that quickly. Okay? Now, there's nothing magic about what we just did. It contains all the same information. It's just how we have displayed that information. Okay? Now, sometimes when constructing tables like this, it's more important to know the fraction or proportion or percent that each category makes up in relation to the total. Okay? In relation to the total. So sometimes we add a third column here, and we call this the relative frequency. okay? And for this relative frequency, we just find the fraction or proportion or percent of each category in relation to the total, okay? So this is just, let me scroll over here just a little bit to give myself room. The ratio or fraction or proportion or percent, these are all different ways to express the same idea of the category in relation to the total. Okay? So, remember our total is 20. So if we wanted the relative frequency of how many A's I have in this course, okay? I have 5 out of the 20 grades are A's, okay? So that's one way to write the relative frequency. Or we could put that into a calculator and convert it to a decimal, okay? So if I take my calculator and write 5 out of 20, I get 0.25. Okay, that's another way to write it. It's the same thing, just a different way to express it. Okay, or if I want to convert it to a percent, I just take that decimal and move it 2 times over. Okay, and so I get 25%. So all of these things are telling me the same thing. Okay, A's make up 25% of the grades in the course. All of these are the same, mean the same thing. They're just different ways to express that information. Generally, in a relative frequency column, you will only use one of these ways to represent it. Okay? I'm using all three just in this example just to show you that there are different ways to express this relative frequency. Okay? Let's do that for the entire chart. So for B, there are 7 B's out of the 20 grades. Okay, if I put that into the calculator, 7 divided by 20 gives me 0.35, which if I convert to a percent would be 35%. Okay, so 35% of all the grades are in the class are B's. C's, that's 5 out of 20 again. We have already seen what happens with 5 out of 20, so we get the same values here. If we were to put into a calculator, we'd get 0.25 or 25%. So 25% of the grades are C's. 1 out of 20 of the grades are D's. 1 out of 20 is, if I can show it to you, 0.05. Okay, 1 out of 20 is 0.05, which if I move the decimal over would be 5%. And then I have 2 out of 20. Now I could put that into the calculator, or I could realize that 2 over 20 is just twice as many as 1 over 20. So I could just double all of this. Okay, if you want to put it into calculator, no harm in doing that. But 0.10 or 10%. Okay, so this is a frequency table, and this particular table has both a frequency column and a relative frequency column. I'm going to point out what the totals of these columns are. Okay, if we add up all the values in the frequency column, so we have 5 plus 7 plus 5 plus 1 plus 2, we're going to get 20. Now that number sounds familiar. Where is that from? That is the total number of data values we had, remember? And that makes sense, right? In a frequency table, everything needs to be allocated to exactly one category. So if we add up everything in the frequency column, we're going to get the total number of data values we have. Okay? In this case, it was 20. What happens if we add up everything in the relative frequency column? And this might be most obvious if we add up the percents. Okay, though we'll get something similar in every case. So I'll start with the percents. 25% plus 35% plus 25% plus 5% plus 10%. Go ahead and add them up. You'll get 100%. Okay? Add a line here to say this is kind of after the table. So the total is 100%. That makes sense. Again, we have all the data values in this table here. So when we add everything up, that's saying we're taking everything. We're taking 100% of the data values. Okay, 100% of the data values are somewhere in this table. If we add them up in decimal form, you'll get 1 instead. 1 is the same thing as 100%. 100% is what 1 is as a percentage. Okay? If you take 1.00 and move this decimal over twice, you get 100%. Okay? So that's going to be important, especially when we get to probability, that little fact. So just keep in mind 1 is equal to 100%. Okay? And if we add up all these fractions, we'll get 20 over 20, which means all 20 of our values are somewhere in this. 20 out of the 20 values are listed here. Okay? So that's what happens in the relative frequency column. So frequency column, if we add everything up, we get the total number of possible data values, right? The total number of values in our data. If we add up our relative frequency column, we get 100%, or 1, okay? Because 100% of our data values are represented in that relative frequency column.